All right, let's talk about something that's literally running your entire digital life, even if you never, ever see it. Databases. They are the silent, powerful engines behind pretty much everything you do online. So let's pull back the curtain.
I mean, really think about it. What's actually happening when you check your bank balance or when you scroll through your feed? What makes all of that work? The answer, pretty much every single time, is a database. They are the invisible brains behind the apps we rely on every single day.
So, what is a database really? At its heart, it's an organized collection of information. But I want you to think of it less like a shoebox full of files and more like a hyper-efficient, super smart digital library. It's not just designed to hold data, it's designed to make finding, updating, and managing that data incredibly fast and easy.
Okay, here's a quick but really important point because this one trips people up. You'll hear database and DBMS used almost interchangeably. Here's the easy way to think about it. The database is the warehouse itself, the big container holding all the information. The DBMS, or database management system, is the forklift driver and the inventory software all rolled into one. It's the tool that lets you actually interact with and manage what's inside the warehouse. So why are these things so absolutely essential? Well, for one, scale. Modern apps deal with just unbelievable amounts of data. Databases are built to handle that without breaking a sweat. They also enforce rules to make sure data stays accurate and consistent, which is kind of important for things like, your bank account. And on top of that, they handle security and are the foundation for all business analytics, letting companies find patterns in all that noise. Now we get to the main event. In the database world, there's this huge philosophical split. For years, one model was the undisputed king, but now it has a serious challenger. This is the great divide. Relational databases, known as SQL, versus non-relational databases, known as NoSQL. To get your head around the first type, the relational database, just imagine a perfectly organized spreadsheet. And I mean perfectly organized. Everything has a predefined place. Data gets stored in neat tables with rows and columns, and every piece of information has to fit that rigid structure perfectly. These databases, the SQL ones, use a strict blueprint called a schema. Before you can add a single piece of data, you have to define exactly what it's going to look like. Their absolute superpower is reliability, guaranteed by something called ACID properties. This makes them the perfect choice for structured data where you cannot afford any mistakes. Think financial systems or e-commerce orders. Now, on the other side of that divide, you've got NoSQL. So if a SQL database is that strict spreadsheet, a NoSQL database is more like a flexible folder. You can throw in all kinds of different documents, some long, some short, some with pictures, some without, and it just handles it. There's no single rigid structure that everything has to conform to. And that flexibility is the whole point. NoSQL databases are schemaless, so you don't need that blueprint up front. They're also designed to scale out horizontally by just adding more and more servers. This makes them absolute beasts for handling massive amounts of unstructured data. We're talking social media feeds, sensor data from smart devices, you name it. So it really all boils down to a trade-off. SQL gives you structure, reliability, and the ability to ask very complex questions of your data. NoSQL gives you incredible flexibility, massive scale, and lightning-fast performance for simpler tasks. It's never about which one is better. It's always about which one is the right tool for the job you're trying to do. But here's where it gets really interesting. NoSQL isn't just one kind of database. That's actually a bit of a misleading name. It's really an umbrella term for a whole family of different approaches, where each one is optimized for a very specific kind of problem. The NoSQL universe really has 4 main flavors, but let's take a quick look at the 3 most common types you're going to encounter out in the wild: document, key value, and graph databases. First up in the NoSQL family, we've got document databases. These have become incredibly popular, and for a very good reason. These guys store information in flexible documents that kind of look like a recipe card. You have different fields and their values. This is perfect for something like an e-commerce catalog. I mean, think about it. A t-shirt needs a size and a color, but a TV needs a screen resolution and a list of ports. In a document database, each product document can have its own unique structure. No problem at all. Next, we have what is probably the simplest, most straightforward database model that exists: key value stores. Just picture a giant 2-column list. In one column, you have a unique key, like a username. In the other, you have its value, like all of that user's profile information. They are built for one thing: speed. They are ridiculously fast at retrieving data if you know the key, which makes them perfect for caching data to speed up a website or for managing a real-time leaderboard in a game.
And finally, we arrive at a type of database that is all about one thing and one thing only: connections. This is the graph database.
In a graph database, the relationships between different pieces of data are just as important as the data itself. This makes them unbelievably powerful for mapping out complex networks. The classic example is a social network. How does it find your friends of friends so quickly? A graph database. They're also the magic behind recommendation engines and sniffing out sophisticated fraud networks.
Now, this world is not standing still, not by a long shot. And the biggest wave crashing over the database landscape right now is, you guessed it, artificial intelligence. You're going to hear the term vector databases a lot more. They're specifically built to help AIs search through things like text and images based on their meaning, not just keywords. We're also seeing AI being used to manage the databases themselves, automating really complex tuning tasks. And of course, everything's moving to the cloud and serverless, offering mind-blowing scale without the headache of managing hardware.
So after all of that, we land on the most important question of all. With all these choices, how in the world do you actually pick one?
Well, here's the secret. It is not about finding the one best database. It's all about understanding what you need to do and then choosing the database that's best suited for that specific task. Let's break it down with this cheat sheet. If you need absolute ironclad transactional integrity, like for a bank, SQL is your champion. End of story. But if you're dealing with huge amounts of messy, unstructured data, like on social media, you need the flexibility of NoSQL. If your data model is constantly changing and evolving, NoSQL is your friend. But if you need to run really complex queries and reports, SQL is still the king.
And that really brings us to the final thought here. The trend in building modern apps isn't about picking one database to rule them all. More often than not, it's about using multiple, specialized databases for different parts of an application. So the real question isn't which one is going to win, but how we can best leverage all of them together to build something amazing. Thanks for joining me.